Homework 4, number 2. Write a Raptor algorithm that asks for two numbers and then outputs the multiples of 5 starting from the second number and going backwards to the first. You may assume the first number input will always be less than or equal to the second number input and that both numbers will be positive. And here's a hint about using the mod or rem function to obtain the remainder from a whole number division. In order to figure out how to solve this algorithm, we'll first notice that we have two inputs, and that the first number will always be smaller than the second number. So they're given an example here of 2 and 13. Then we'll see that we have outputs. We're supposed to output the multiples of 5 starting from the second number and going backwards to the first. So the example provided, if we're given the numbers 2 and then 13 as inputs, then we would expect to see the multiples of 5 starting with a larger number working our way backwards. So the first one we would come to is 10 and then 5. It looks like I'm going to have to loop from the larger number, the number 13, backwards to the number 2, and every time I see a multiple of 5 I'm going to output that to the screen. But before solving this problem, I want to solve a simpler problem. Again, we'll use the inputs of 2 and 13, but then instead of outputting only the multiples of 5, we'll try outputting every value from the large number to the smaller number. And once we do that and get that working, then from there we can see if we can then output only those values that were multiples of 5. So getting started, we remember that our loop has a format called item, where I is initialize, T is for test, E is for evaluate or execute, and M is for modify. Often we'll set our loop counter, I'll use I, to the value 1, and then our modify, we would increase the value of I by 1. And test would be our exit condition, which is whenever I is greater than the number of loops. But since we're counting backwards, that's going to change a little bit. This time, instead of setting I to 1, we'll set I to the last value that's entered. In this way, it would be the value 13. And then, instead of counting up, we'll count backwards with I. And then we'll exit, not when I is greater than the number of loops, but whenever I gets to be less than the first. Now what do we want to do in the middle? We just simply want to output whatever the current value of I is. So we're going to give that a try in Raptor and see what happens. We'll start by adding our two inputs, and then after that we'll add the loop. So the first input is the first number, so I'll just ask the user, what is the first number? We'll call that first. And then the second input is supposed to be that second number, so I ask the user, what is the second number? We'll call that last. And then I'll add a loop, make sure I add an assignment for my initialize and for my modify. Again, we're going to initialize by setting I to last, and we'll modify by setting I to I minus 1. And then our test condition should be I is less than first. So in this way, we start off, I is going to be set to last, and given our example of 2 and 13, I would be given the value of 13. And each time through the loop, I would get smaller by 1, and eventually the value of I would be 2, which is the same as the value of first. So when I is 2 and when first is 2, we wouldn't exit, we would go through the loop one more time until I becomes 1, which is less than 2, and then we would exit. So what do we want to do in the middle? What's our evaluation or execute step? Well, simply we're going to output I. So let's see how this works. We'll run our algorithm, and we'll do it with the inputs of 2 and 13. When I do this, I'd expect to get all the numbers from 13 to 2 in reverse order. We see that's precisely what I get, starting with 13 all the way down to 2, counting backwards. So how do we output only those numbers that are divisible by 5? Well, before we do that, let's take a look at what's actually happening in division. If we do 5 divided by 5, the answer, of course, to that is 1. We can also think of that as 1 remainder 0. Of course, if we did it in wrapped, we'd get exactly 1. But one way to think about 5 divided by 5 is 1 remainder 0. If we did 6 divided by 5, that's 1 remainder 1. Again, of course, the calculator would give us 1.2, but a way to think about it is 1 remainder 1. 7 divided by 5 is 1 remainder 2. 8 divided by 5 is 1 remainder 3. 9 divided by 5 is 1 remainder 4. And 10 divided by 5 is 1 remainder 0. If we look at this, everywhere that I have a remainder of 0, I have a multiple of 5. So what I need is a mathematical function that gets just the remainder and not the quotient. And that's where our mod function comes in. So if instead of doing 5 divided by 5, we did 5 mod 5, the answer to that is 0. And again, that comes from the value of the remainder. So 6 mod 5 is 1. 7 mod 5 is 2. 8 mod 5 is 3. 9 mod 5 is 4. And 10 mod 5 is 0. So let's try this out in Raptor. Instead of outputting every value, I only want to output those values where 5 mod 5 is 0, or the value of I mod 5 is 0. So I'll use a selection, and sometimes I'll output I and sometimes I won't. Specifically, I'll output I only when I mod 5 equals 0. So let's run a Raptor algorithm again and see what that looks like. I'll run it again with the values of 2 and 13, and this time I'd expect only the multiples of 5 to be output, 10 and 5. And sure enough, that's what we have. Let's try another. This time we'll do 5 and 28. And here we've got all the values 25 through 5 counting backwards as multiples of 5. So it looks like our algorithm's working. We'll try a test against server. And it seems to be working against all the test cases. So we'll assume that we have done everything correctly and we'll move on to the next problem.